Let's consider the rest of the question and why we've chosen that step to do the critical value. So the question is asking us calculate the minimum value of n such that the probability of a type 2 error is less than 0.5. Now let's interpret what that means. So we're asked find n such that, or the minimum value of n, such that the probability, and what is a type 2 error? We've accepted the null hypothesis when it's actually false. So probability we accept h0 when, or given that h1 is true. And the version of h1 being true that they've given in this question is the fact that mu is equal to 14.9. So it's kind of unintuitive why that completely corresponds, but that's how statistics works. And I'm not a statistician, so ask them. But what they want you to take in this question for h1 true is the fact that we're going to find this probability, or what we want this to be less than 0.05. Probability we accept h0, given that mu is equal to 14.9, right? Which is this would be a type 2 error. We know, in fact, that h1 is true because mu is not equal to 15. It's equal to 14.9. It's something less than 15. But we're still going to accept the hypothesis. And we want this probability to be minimized. We want to find n such. Okay, so what does physically this mean computing in terms of an equation? So we've accepted h0. What does that mean? That means that x is greater than or equal to c, right? Because we've said this is the point where we would reject it at a 0.1 level of significance. This is the level that we would accept it. Because of how it works, right? If we're saying it has to be this far along the thing in terms of length, so to speak, the critical value. So this, such that mu equals 14.9 is less than 0.05, and we can actually rewrite this inequality because we're gonna be again working with the canonical normal z equals x minus mu over sigma. So we're going to want to have it in this direction. The probability that it goes up to something, right, is less than things. So specifically, we need to find C such that this area here is less than 0.05, or the value of it is less than 0.5. So what does that correspond to in terms of actually setting up sorry, there should be a greater than sign there. Got to flip both signs. This thing should be greater than 0.95. Where this C in this whole area is 0.95. So again, I'm not doing a brilliant job of explaining this, but if you sort of think through the steps and logically what we're going through, this structure statistically makes sense, right? What we're saying is we're just trying to find areas on graphs that correspond to certain things being true. There's only certain eventualities that we can do given type 1s or type 2 errors. Certainly this thing holds true, and this step here is, again, just if this area is less than 0.05, so that would be this area here, this thing is greater than 0.95 right there. The two statements that have to hold true at the same time. Yeah, they're mutually exclusive, so to speak.